see the arrangement of resistors denoted by the numbers 1, 2, 3, 4, 5, 6, 7, 8. And we have to find out, let's say, what is the equivalent resistance between A and B. When we say we have to find the equivalent resistance between A and B, it is saying something like this, that is, current enters from A and it exits from B, or it enters from B or exits from A. Assume that there is a battery which is connected like this, and we have to find what is the equivalent resistance between A and B, right? For the flow of current, we obviously need a closed path. So over here we find that this is a closed path, this also gives a closed path. But obviously the current cannot go over here, because as soon as we put a battery, the whole circuit is sensed at one go. It is not something like this. The current comes over here and it comes over here to this dead end and finds that there is nowhere to go and it returns back. No, it doesn't happen like this. As soon as, if we talk about electronic current, as soon as electron is pushed into this circuit, one electron enters into this positive terminal, so that the battery maintains its electrical neutrality. So if you have to find what is the equivalent resistance between A and B, then certainly that there will not be any current which shall be flowing in this arm or this arm. So these, they go off. So this and this will not be there. They don't have any use. Now what we see is, that is 2, 5 and 7, they are just joined end to end. So these are in series. These 3 and this 4, they are in parallel. Then this and this, they are in series. That is 2, 5 and 7, we can find they are end to end, and we can find a resistance equivalent to this series combination. Now this and this, they are parallel because they are splitting over here simultaneously and reuniting at the same point. So as a result, so that R dash and 4, they are in parallel, we can take them out and we can replace them one by one single resistor, that is R double dash. And now we see that is 1 R double dash and 6, they are in series, and we can find the equivalent resistance. In the same question, if we have to find what is the equivalent resistance between X and Y, then we find, then we assume that is, suppose the current enters over here and exits over here, that is, we can assume it to be joined by a battery. The whole circuit is sensed at one go. So now obviously the current will not be flowing in this arm, and it will not also be flowing in this arm. So that's why we can remove these two. So now this and this, they are in series. This and this, they are in series. This and this, they are in parallel. We can find the equivalent resistance of the combination. Then this and this, they are in series, and we can find the equivalent resistance.